Hello everyone. In this video, I'm going to talk about chapter 1, the scientific method. When we talk about scientific method, we just need to remember some systematic methods in sciences. So we are going to learn what is a scientific method, how to apply that in our daily life, and if possible, how to explore this scientific method for our career. First, let me define scientific method. Please look at this slide. It says the scientific method is the process used by scientists to explain observation in nature. So we are going to work on some terminology here. This is a process. So we are going to work on one method that it happens in our universe and is going to be used by scientists. You are not scientists, so you may use the scientific method because we are going to learn this method to apply to explain the observation is on the globe in the universe. But one thing we should know, the reason we call that scientific method, because this process is going to be repeated several times, is going to be checked by some person. They work on they study the events, they study the observations. Scientific method has four main components, four main steps. So please understand they should be in order. Making observation, writing a hypothesis, doing experiments, and proposing a theory. We are going to know what does that mean each step of this scientific definition. Please keep in mind we need to consider these four steps: observation, hypothesis, experiments, theory. It means a scientific method starts with one observation. We need to observe and see something. After that, you think about that observation. You think how to explain that observation. We call that hypothesis. Then, to confirm your hypothesis is right or not, is correct or not, you need to do some experiments. And whenever the result of the experiments confirm your hypothesis, we call that a summary, theory, or conclusion. It depends on our study. We may have a general conclusion, general summary, or we call that in sciences theory. So I wanted to show you in our daily life, we may do this systematic process, but we don't call that scientific method because we don't do this in the labs or in our science courses. As long as you have a general conclusion, as long as you have a summary for your study, you may consider that one as a similar method. We call that scientific method. So right now, I'm going to talk about each step of this scientific method. First one is observations. So you have to see something. For observation, we have two different forms. Observation can be happened by our naked eyes. You can watch, you can see, and you may measure specific parameters, like you are going to measure length of one pen. You may use a tool to measure length of one book. So we call that observation as well. So measurements are one part of observations. Please understand, when we say observation, we are talking about not only our watching, but also our measurement considered as observation. As you see here, it says hypothesis is one statement that explains our observations. For example, I see one pen. I use a ruler to measure the size of the pen. So after I measure the size of the pen, I may say, for example, it's 2.1 centimeter. 2.1 centimeter. So I accept that the size for this pen is 2.1 centimeter. This is a small pen. To confirm my measurement is correct or not, I may do one more. I may need to do one more experiment to confirm my hypothesis is correct or not. I may use another ruler. I may use meter stick. I may use another tool to measure the size of that experiment. So at that time, I may confirm my hypothesis. I'm going to check the answer for this observation 2.1 centimeter is exactly correct or not. If it confirms that, if the experiment part confirms that, I may say the size of this pen is 2.1 centimeter. I can conclude to have this size of my pen. In scientific method, we call that theory. So we use different experiments to confirm our hypothesis, or a group of people, a group of scientists, they talk about that event. So at that time, that model describes our hypothesis by the definition of some minor steps. Please look at this slide and read this slide by yourself. Think about this and see how it works. Are you able to find out which one is which? As you see here, first we need to have observation. We need to see something happens. Observation is the first step of our scientific method. Hypothesis, this is your thought. This is your explanation for observation. After hypothesis, to check this hypothesis is correct or not, we need to do one experiment. Doing experiment always happen the hypothesis. So when it's done, I may have another hypothesis. As you see here, we may have hypothesis number 2, the second one. Again, after hypothesis, we have experiment. Look, we may have a loop of hypothesis experiments. We have only one observation. We start with one observation at the beginning, but we may think, we may do the experiment to check that one is correct or not. At the end, if you can conclude or if you can summarize your hypothesis and experiment result, we call that theory. We call that conclusion. So this example is not example of scientific method, but I wanted to find a similarity between the scientific thinking, the scientific procedure you may do in your daily life, and scientific method. For scientific method, we call that theory, but here we may call that conclusion or summary. So they are something I wanted to make sure you understand that. I may ask you to think about one of the scientific methods or scientific thinking that you did in your daily life. If you have the cell phone, your cell phone battery is dead, there is no charge for that, or if you have your computer, it doesn't turn on, the webcam doesn't work, or any other examples. You may have 100 examples regarding this scientific thinking. Right now, I may ask you to watch this example, see that one, read them, and see are you able to find which one is which in this learning check question. All right, guys. Right now, I'm thinking about first one. A blender does not work when plugged in. What do you think about that? So if we are going to start our scientific method, I may consider that one as an observation. The blender motor is broke, so whenever it's broken, so probably we are going to call that our hypothesis because it doesn't work. How about C? You are talking about plug has malfunctioned. So this is another hypothesis as well. How about D? Absolutely, you are going to call that one correctly. We call that experiment. And the last one, we call it a general conclusion or summary. As you see here, we may have different types of hypotheses. We may have more experiments to do, but always we have one observation and one theory. The last one, the blender needs repair. This is the general conclusion. So it's going to cover all of the activity we did before this conclusion. That is why we may call that theory in our scientific methods. So they are answers for the last question. Right now, I'm going to have a quick review here to make sure you understand that one, and we are done with this section. Scientific method. Again, this is a systematic procedure we apply to explain the natural event. This method we call that scientific because we may use that one in our labs every single day. But if we are going to find a similarity between the scientific method and our daily life, we may have some procedure, we call that scientific procedure. We may call that scientific thinking. All of them start with one observation. Again, observation can be categorized by two forms. If you are going to use your ruler to measure something, if you are going to use any tools to measure something, we may call that observation. And if you don't use any tools, we may call that observation as well. Right now, I'm going to call each type of observation by a technical terms. Qualitative observation, the first one, qualitative observation. We may use our naked eyes. So color is qualitative observation. If you look at the book, you may call the color for that. You may observe the color for this one. So we call that qualitative observation. What other information you may find for any object if you look at them, if you watch them? You may talk about color. So color is one of the qualitative observation. You may talk about a state of matter, solid, liquid, gas. You may talk about shape, what shape it has. So you are talking about qualitative observation by your naked eyes. Quantitative, the second type of observation is based on our measurement. So, for example, mass, for example, temperature. So I may say 75 degrees Celsius, 75 degrees Fahrenheit. So I'm talking about a measurement. Measurement is quantitative. We talk about the quantity, numbers. So size, weight, so they are examples of quantitative observations. Right now, I'm going to talk about any other examples of scientific methods. Scientific methods, if we are going to work on them and study them, we may find some related concept regarding them. One is law, scientific law. We are going to know what does that mean. Scientific law, they are statements that summarize past observations and predict future ones. So this is a law. Based on the past observation, we can predict something in the near future in the same conditions. So Whenever we talk about law, in general, we talk about mathematical equations, mathematical formula. So physics, it has many laws. In chemistry, because we may have some exceptions, we may call them theory. So I'm going to talk about it a little bit later, and I don't want to confuse you right now. So this is a definition for law. We can summarize the past observation and we can predict the future ones. For scientific methods, after observation, we have hypothesis, a tentative explanation for our observation. We need to test that one. We need to check that one. We need to do investigation. This investigation, we call that experiment. Experiment, this is the third step of any scientific methods. We are going to check, we are going to test the hypothesis. And finally, theory. This is a proposed model or explanation for our observation. Right now, I told you I'm going to talk about law and theory. I'm going to find what is the difference between these two. Please read these two basic definitions, and I'm going to write the difference between these two by another form. As I already explained for you earlier, laws in general predict what will happen. So we have prediction as well. So for laws, we have prediction. But for theories, we are going to explain. We are going to explain. We have explanation. In general, laws can explain as well. So it looks laws cover theories as well. But if we are going to know what are exact difference between them, so we may write laws in general, they predict, but for theories, we explain the event or observation. Another one, it says without explanation, we may predict. So if we drop this one, we have only prediction, we call that law. So one thing we should know regarding the laws and theories, theories may have exceptions, may have exceptions. But for law, there is no exception. There is no exception. Law always is law. There is no exceptions. But for the theories, we may have exceptions. For example, I may say all solids, all metals are solid at room temperature. All metals are solid at room temperature. Whenever I say all metals are solid at room temperature, so we are going to talk about this prediction as well. So if I discover a new metal, it must be a solid. But I may say all metals are solid at room temperature except mercury. Except mercury. I'm talking about one exception. So right now, when we have exception, we don't call it law. We call it theory. It means we did some experiments on the materials, metallic materials, and we found out they are solid except one of those. We call that liquid. There is no guarantee if I discover a new compound, a new metal, if I or other scientists discover a new metals we have in the metallic form. So we may have in another state of matter. So exceptions make this one for us as a theory. Another one, whenever we talk about laws, laws never expire. No expiration date for laws. But for theories, we have expiration. We have expiration time. So, for example, we say Dalton's atomic theory. We may say Bohr's atomic theory. We may say nuclear model. So they are theories or model, and after progress, after discovery or something new, we learn some new assumption. So the theory is already expired, and we don't use that one for our studies. So theories or models can be expired, but laws never expire. I may ask you to find the difference between the theory and laws in the chemistry. Memorize these three for yourself. Triple E. Explanation, exceptions, and expiration for theories. And we don't have them for laws. We don't need to work on this section by details as long as you should know how many steps for scientific method and what is the difference between the law and theory. It would be enough for this section. Hope you learned the difference between the laws and theories and the steps of the theories as well. Thank you for watching this video.